inequalities. So our first example, negative 3x minus 5 is greater than or equal to 10. So my goal is to isolate the x. So I'm going to add 5 to both sides. We get negative 3x is greater than or equal to 15. And now this part is where it differs from just an equation. I need to isolate x by dividing by a negative 3. So when you multiply or divide by a negative, when you have an inequality, you have to reverse the sign. So dividing by negative 3 on both sides gives me x. And now it becomes less than or equal to a negative 5. So that's inequality with just 2 parts. We also look at inequalities that are in 3 parts. My goal here is to just get an x in the middle of my inequality. So whatever I do to one piece, I need to add 5 there. I need to do it to the other parts as well. So I'm going to add 5 to each piece, and I get 4 less than or equal to 2x less than or equal to 12. I still need to get the x by itself, so I have to divide by 2. And again, I have to do it to each piece. So dividing each piece by 2, I get 2 less than or equal to x, which is less than, this is less than, sorry, just less than 6. So if I were to graph that, I'd have a closed circle at 2, an open circle at 6, and the shading in between. So both of these first 2 examples were linear. We also are going to look at nonlinear. So for my example, I have x squared plus 2x minus 8 is less than 0. So I want this thing to be negative, because that's a less than 0. Now when we're solving nonlinear, the first thing is one side of the inequality has to be 0. Just like if we were solving a quadratic that was an equal sign, it has to be set equal to 0. The inequality has to be set to 0. So I'm going to factor this, and I get x plus 4 times x minus 2 less than 0. And again, just like any other quadratic, I have to set each term equal to 0. So x plus 4 equals 0, and x minus 2 equals 0. So my solutions would be a negative 4 and a positive 2. I'm going to go to my number line and put negative 4 and 2. Now, because it's less than 0, it can't equal 0, I have to put open circles at negative 4 and 2, because those aren't included. And then I want to know when this thing is negative. So I'm just going to pick test points inside the interval to see where I get negative and positive. And I want to pick as simple numbers as I can. And so I'm going to pick negative 5 for the interval that's less than negative 4, 0 in between negative 4 and 2, and then 3, just something bigger than 2. So when I plug in negative 5, I'm going to plug it into this factored form because it's just easier for me to do. Negative 5 plus 4 is negative 1. Negative 5 minus 2 is negative 7. So negative times a negative is going to give me a positive value. When I plug in 0, I get 4 times negative 2, which is a negative. And when I plug in 3, I get 7 times 1, which is a positive. So because I'm looking for negative values, my solution is this between negative 4 and 2. And I want to do one more nonlinear. And this is a rational. So I have x plus 6 over x minus 2. And I want it to be greater than or equal to 0. So again, this is already set to 0. So I can start looking at it. and I want to find what makes it 0 or undefined. And these are called critical values. And that again is where the function is 0 or undefined. So what makes it 0 is -6. Because x plus 6, when you set that equal to 0, you get x is equal to -6. And because it makes it 0 and this is greater than or equal to 0, I'm going to do a closed in circle. And the bottom, what makes it undefined, is 2. Well, it can never be undefined, so I know that has to be an open circle. So those are the numbers on my number line. And again, I'm just going to pick stuff in the interval to see what makes it greater than or equal to 0, which just means it's positive. So in this interval, I'm going to pick -7, 0, and 3. So when I pick -7, I get -7 plus 6 is -1 over -9. So negative divided by negative is positive. When I pick 0, I get 6 divided by -2, which is -3. And when I pick 3, I get 9 over 1, which is a positive. So where it's positive is the intervals less than -6, or less than or equal to -6, or greater than 2. And I'm going to write this out in interval notation. So -infinity to -6, and I'm putting a hard bracket by -6. And then the other part of my solution set is 2, which is not included, so I have a parenthesis, to infinity.